This is trig. It's kind of fun once you get the hang of it. It may be a little bit tricky, but hopefully this first section we walk you into it so that next time when we bring the pain, as Mr. Buzz was saying, that it works out just great. So let's take a look. First of all, these are the trig identities, and you should know all these. Cosecant x is the same as 1 over sine x. Secant x is the same over 1 over cosine x. And remember, the easy way to remember that is the sine and cosine, secant and cosecant, they're both c and s, but they're opposite. Cotangent x is just 1 over tangent x. Now down here we have our quotient identities. In other words, tangent x, if I were to write it in sine, and cosine would be sine divided by cosine. And then, of course, the reciprocal cotangent x would be cosine over sine. These are things you want to make sure you know, and the quicker you know them, the better off you're going to be doing these trig identities. So, let's talk about identities here. Let's do this first one. We want to simplify this to a single trig expression or any kind of expression. Let's take a look, see what we can do. So the first thing I'm going to do, and we'll talk about tricks in a minute, first thing I like to do is I like to write it in terms of sine and cosine. The less I have to compare, the better off it's going to be. So I know that cotangent u is just cosine u over sine u. And then we're going to multiply that by secant. Well, that's 1 over cosine u. And sine u is here. Alright, now the great thing is, remember, it's on top and on bottom, that equals 1, because sine u divided by sine u is 1. They cancel. Cosine u divided by cosine u is 1 also. So what is left here? The one expression we have, it's not necessarily a trig expression, I'm sorry about this one, but it goes down to just the number 1. Let's take a look at this. I'm going to rewrite this as cosine alpha. Secant is 1 over cosine. Alright, and this is going to be, I'm going to multiply this here, so that's 1 over cotangent. Alright, let's change that. Well, first of all, we notice right off the bat these cancel. So really, I'm just down to 1 over cotangent alpha. And I know from earlier that 1 over cotangent alpha is tangent. And there is our single trig expression. Alright, so right now, just take a look. I'm just manipulating these with algebra, things I know, facts I know, changing it all into sine and cosine, and then kind of getting it down, working it down to a single expression. So before we move on, let's take a look. What is the identity of the scrawny kid who becomes Captain America? Take a second. Who looks like this scrawny guy right here that turns into the mug? It is, of course, our favorite Bean, Mr. Bean. Right there, kind of looks just like Chris Evans right there, right? So Mr. Bean turns into the mighty Captain America. Of course, that's his secret. What? Identity. That's right, that's what I'm kind of trying to get to here. It's all about identities today. So let's talk about verifying identities. Now, verifying identities, that's the nuts and bolts of what we're going to be doing, all right, for the next couple of sections. And essentially, this is going to be proven. All right, now, a couple things. First thing is, you have to show the steps. All right? There is no answer here. All right, the answer is, I know that cosine x times tangent x equals sine x. That is the answer. I want you to show me the work to get to that answer. All right? Here's tip number 1. Start with the more complicated side and transform it into the other side using basic identities, algebra, or other established identities that we know. Alright, so let's take a look here. So I want to get it to sine x. So the first thing I'm going to do is convert this to cosine and sine. So I know that cosine x times tangent is sine x over cosine x. I know that cosine x divided by cosine x cancels out, and I'm left with sine x equals sine x. Pretty easy one right here to start you off with. But notice I started with this, the more complicated side, got it over here to the sine x, and it does check out. It is verified. Let's try a little bit harder one. Not much. Secant theta. Well, I know secant theta. I'm going to change that to 1 over cosine theta. And I multiply that by cotangent theta. Well, that is cosine theta over sine theta. All right? And our goal is we want to get to cosecant theta. All right, so these cancel, right? Because cosine divided by cosine is 1. So I'm left with 1 over sine theta. And I know that 1 over sine theta, another name for that is just cosecant theta. So in the end, cosecant theta does equal cosecant theta. Now, a lot of you are going to be like, oh, well, right here I see, like 1 over sine theta, and that's just cosecant theta. All right, here's the deal. Again, this is all about verifying. It's all about verifying. We need you to show all these little steps. And I know, for some of you, that's a real pain, and I am so sorry. I want to cry a river for you. Oh, no. All right, tough it up. It's going to be better. The more work you show, the better off you're going to be. These today aren't as involved. The more you can do and show, the better off it is going to be next time. Just trust me. They get a little bit trickier on the next time. So here are some tips. You may want to pause the video and just write these down. These are not all inclusive, but there's some good things to do. So we've already looked at this first one. Express each function in terms of sine and cosine, then perform algebraic operations. We've been doing that a lot. That's all I've really done. It is a huge one. I'm telling you, get it into sine and cosine. Things cancel out, and you can work with that much easier. Tip number 2, multiply or factor, combine fractions, or split fractions. All right, combining fractions, maybe you have to get a common denominator. All right. Maybe you have to get a common denominator. Splitting fractions. Maybe you have x over y equals z, and you split it. X over z plus y over z. And you'll see, we'll do one in a minute, how this is actually very handy and comes in quite helpful. And the other thing is always keep the other side in mind. All right? You want to know where you're going in order to know how to get there. So let's take a look. Oh, here we go. What's the real identity of the Norse god of thunder? Ooh, look at that. The ponytails and all that stuff. Yeah, the girls love this guy. Well, who is it? Oh, that's right. It's our favorite Norse god of thunder. It's Mr. Kelly. Nice. Way to go, Mr. Kelly. Looking sharp right there. Boom. He's the real Thor. So, let's try this one. This one looks a little bit trickier, but I think we can handle it. Now, some of you are going to be like, we want to start with the more complicated side. Which side is more complicated? It's a toss-up. And I'll be honest with you, sometimes you're going to start on one side because you think it's going to be easier to work with, and you realize you can't do anything. So you go to the other side. To me, I see a fraction. I think fractions are more complicated. So I'm going to split this fraction. I'm going to do 1 over cosine theta plus sine theta over cosine theta. Just split it up, and we're headed to our goal of equaling secant theta and tangent theta. Well, what is 1 over cosine theta? See, this is why it's nice. 1 over cosine theta is secant theta. And what is sine over cosine? Well, that is tangent theta. See, it looked a little bit tough right at the beginning, but it's really just one step, and then we verified it. All right? I want you to pause the video and try this one all on your own. Just try it. Use some algebra. Maneuver the stuff around. I'll give you a hint. Start on this side. All right? Try that one all by yourself. So the first thing I did was I rewrote this. All right, right here. I just rewrote it so that now I know that when I divide by a fraction, I multiply by the reciprocal. I combine these, so it's cosine over sine. And then I know that cosine theta over sine theta is cotangent theta, and we are good to go. All right, whose real identity is behind that beast known as the Hulk? All right, the beast, don't make him angry. It's Mr. Brust. That's right, Mr. Brust is the Hulk. There's mini Hulk right there, all right? But Mr., look at that. He's just so angry. Why are you so angry, Mr. Brust? Why? All right, so let's try this one. Here we go. All right. This one, we need to do some algebra. Going to distribute. So I'm going to do sine theta times 1 is sine theta plus sine theta times secant theta. All right, and we wanted to head towards this, which is good. We already have the sine theta. I'm going to rewrite that. So I have sine theta plus sine theta. Secant is 1 over cosine theta. Excuse me. And then sine over cosine. And we know sine over cosine is, of course, tangent theta. And that is what we wanted. Now, could you have started here and gone that way? You could have. It would have been a little tricky. You would have had to factor it, but that's okay. No problem. All right, we verified it right there. There's a couple of different ways to do these, all right? I'm just showing you what I think is probably the easiest way. All right, pause the video. You try this one. All right, so the first thing I did was distribute it here. Cosecant times cosine theta, cosecant times sine theta. I rewrote everything in terms of sine and cosine. I multiplied these. I got cosine over sine, sine over sine. Sine theta over sine theta is 1. Cosine over sine is cotangent. All right. Now again, do you need to show every step? You certainly need to be able to go from here to here. You can't skip steps. All right. I know a lot of you are big on skipping steps. This is not about skipping. This is about showing you how to do these problems. All right. Let's have a little bit of fun with trig now. Do these pretty quick. Let's review. Just going to distribute. 6x squared plus 8x. It doesn't change much. Tangent x times cosecant x minus tangent x. Of course, now, can I simplify this? Well, this is sine x over cosine x. And cosecant is 1 over sine x. So we can reduce this a little bit. So that's 1 over cosine x minus tangent x. And that, of course, is secant x minus tangent x. Just using the algebra, combining it with a little bit of trig. Again, so this is going to be 6x squared plus 8x minus 15x minus 20. Combine 6x squared minus 7x minus 20. Same thing applies here. Sine x times sine x is not sine x squared. We write that as sine squared x. Alright? In your calculator, you can write that. It's equivalent. Alright? But when you see this, sine squared x, that's what it means. Alright? Plus sine x times cosine x. And then distribute the negative cosine x, sine x. And negative cosine times cosine is negative cosine squared x. These are the same thing. Alright, they don't look the same because they're in different order, but sine x, cosine x is the same as cosine sine. So they cancel, so we're left with sine squared x minus cosine squared x. Alright. Scoot down a little bit here. Tangent x minus 1 squared. Maybe remember right now that that's the difference of squares, and you know exactly how to get to that formula, or excuse me, not difference of squares. Perfect square trinomial. Maybe you can get to that right now. But if you can't, just remember that it's tan x minus 1 times tangent x minus 1. So that's tangent squared x minus tangent x. And then negative 1, or minus tangent x, plus 1. And we have 2 of these, so it's tangent squared x minus 2 tangent x plus 1. Just showing you now that you can do all that algebra you already know while doing it with trig. So again, so we can factor out a greatest common factor. I know the greatest common factor here is 3x. So I'm left with 4x minus 7. I just took a greatest common factor out. When I look down here, what's my greatest common factor? Well, it's sine x. If I take a sine x out of here, I have 1 sine x left. If I take a sine x out of here, I have just a 1.